Okay, so on to question 8. Cyclopropane C3H6 reacts to form propene in the gas phase. The reaction is first order in cyclopropane and has a rate constant of 5.87 times 10 to the negative 4 inverse seconds at 485 degrees Celsius. If a 2.6 liter reaction vessel initially contains 725 torr of cyclopropane at 485 degrees Celsius, how long will it take for the partial pressure of cyclopropane to drop below 104 torr? Okay, so this question tells us a lot of things. It tells us that we have a first order reaction. And because we know that this is a first order reaction, then we can write down the first order integrated rate law. So there are different types of rate laws. You can have second order and third order as well. But in the case of our question, we have a first order rate law. So this tells us that we can write down this equation as ln of the pressure at time is equal to negative kT plus ln P naught. So I'll define what each of these variables mean. So P sub T is the pressure at time T. And we have K. So K is our rate constant. So this was given in the question, which was 5.87 times 10 to the negative 4 inverse seconds. And next we have P naught. And this is just initial pressure. So before the reaction takes place. Okay, so we know that the reaction vessel initially contains 725 torr. So we can say that the initial pressure is 725 torr. And we know that the pressure at time t, which is what we're trying to solve for, is equal to 104 torr. So now all we have to do is plug in our variables. I'll plug in our values and solve for the unknown, which is time. So how long will it take for the partial pressure to drop below 104 torr? So now let's plug in our values. We'll have ln of 104 is equal to negative k, which is the 5.87 times 10 to the negative 4 inverse seconds times t. I didn't give myself enough room, but let's just continue it here. Plus ln of our initial pressure, which is 725 torr. Okay, so now let's try to simplify this. So when we take the ln of 104, you get around 4.64. Negative 5.87 times 10 to the negative 4. And when you do ln of 725, it's around 6.586. Okay, so now let's just try to solve for t. 4.64 minus 6.586 divided by negative 5.87 times 10 to the negative 4 inverse seconds is equal to t. Plugging that all in, we get t is equal to 3,308 seconds. And we can just convert this to minutes, which is like 55 minutes. Okay, so it will take 55 minutes for the partial pressure of cyclopropane to drop to below 104. Okay, so let's see what the junior tutor said. A first order reaction means that the rate of the reaction is linearly dependent on the concentration of pressure of the reactant. This is described by the equation below, which is referred to as the first order rate law equation. Since the reaction is in gas phase, the equation is written in terms of pressure. Rate is equal to K times the pressure of gas A, where K is the rate constant for a first order reaction. The unit is time inverse of time. So this equation can be converted to the equation below, which is known as the first order integrated rate law expression. Okay, so they have the same equation, pressure of gas A after time, the rate constant, time elapsed since the start of the reaction, and the initial pressure of gas A. So using this, we can calculate the time required for the pressure of cyclopropane to drop to 104 torr. And they got 3,308 seconds. So this solution is correct.